Chapter 8, Simple Machines. This is a schedule for the rest of the semester, or the rest of the chapter, as well as the rest of this month. I want you to notice that we will be doing the Rube Goldberg machine presentations on the 25th and 26th. The lesson outlined for today are Simple Machines quiz, some quick notes on Simple Machines, a Simple Machines worksheet, and finally a closure activity. I want you to remind you to read Chapter 8.4 prior to coming to class on the next period, watch a screencast, and make sure that you do the practice quiz. The learning targets for this unit are: I can identify the 6 types of simple machines, I can explain how the operation of simple machines change the applied force and distance moved, and finally I can calculate the mechanical advantage of a simple machine. We will watch a Bill Nye video on simple machines prior to moving on. The 6 simple machines are inclined plane, a screw, a wedge, a lever, a wheel and axle, and pulleys. Very quick definitions. Energy is the ability to do work. Work is equal to force times distance, and force is a push or a pull. The Egyptians used simple machines to build the pyramids. One method was to build a very long inclined plane out of dirt that rose up to the top of the pyramid very gently. Blocks of stone were placed on large logs, which is another type of simple machine, the wheel and axle, and pushed slowly up the long inclined plane to the top of the pyramid. An inclined plane is simply a flat surface that is higher on one end. Inclined planes make the work of moving things easier because they change work input and work output. The work input is the amount of work done on a machine. Input force times input distance. Work output is the amount of work done by the machine. Work output force times output distance. This is a quick example of how you would use that. The mechanical advantage of an inclined plane is equal to the length of the slope divided by the height of the inclined plane. While the inclined plane produces a mechanical advantage, it does so by increasing the distance through which the force must be pushed. A screw can be calculated, the mechanical advantage of a screw can be calculated by dividing the circumference of the pitch of the screw. The pitch is equal to 1 over the number of turns per inch. Wedges are 2 inclined planes joined back to back. Wedges are used to split things. Mechanical advantage of wedge can be found by dividing the length of either slope by the thickness of the big end. As an example, assume the length of the slope is 10 inches and the thickness is 4 inches. The mechanical advantage is equal to 10 divided by 4, or 2.5. As with the inclined plane, the mechanical advantage gained by using a wedge requires a corresponding increase in the distance. A first-class lever, the effort force is on one end, the fulcrum is in the middle, and the resistance force is on the other end. This multiplies the effort force and changes its direction. The mechanical advantage of the lever is the ratio of the length of the lever on the applied force side of the fulcrum to the length of the lever on the resistance force side of the fulcrum. Here are some pictures of some very simple first-class levers. Second-class lever, the resistance load is between the fulcrum and the effort force. The effort force moves farther than the resistance, and it multiplies the effort force but does not change the direction. The mechanical advantage of a lever is the ratio of the distance from the applied force to the fulcrum to the distance from the resistance force to the fulcrum. A couple of examples of second-class levers. Third-class lever does not multiply the resistance force. The resistance moves further than effort, and it multiplies the distance the effort force travels. The mechanical advantage of the lever is the ratio of the distance from the applied force to the fulcrum to the distance of the resistance force to the fulcrum. Some examples of a third-class lever. Pulleys are wheels and axles with a groove around the outside of a pulley that needs a chain or a rope to tie around it to make it work. A fixed pulley changes the direction of the force, however, it does not create a mechanical advantage. On the other hand, a movable pulley, the mechanical advantage is equal to the number of ropes that support the movable pulley. In this case, you have one here on the left side and one here on the right side. So the mechanical advantage for this movable pulley would be 2. The effort force needed to lift the load is less than half the weight of the load. The main disadvantage is it travels a very long distance. In this case, you have 2 here, and it would be a mechanical advantage of 2. If you rearrange the strings, you could get a mechanical advantage of 3. A wheel and axle. The axle is stuck rigidly to a large wheel. Fan blades are attached to the wheel. Then the axle turns, the fan belts spin. Mechanical advantage of a wheel and axle is the ratio of the radius of the wheel to the radius of the axle. Gears are another form of wheel and axle. Each gear series reverses the direction of rotation of the previous gear. The smaller gear will always turn faster than the larger gear. And finally, Rube Goldberg machines. Here is an example of a Rube Goldberg machine. Again, read Chapter 8.4, watch a screencast, and finish the practice quiz.